So this is our Merleau Ponty reading group. We're continuing our reading of the structures of behavior. We are at page 101 of the English translation. So the last couple times we have been looking at some of the lessons that he wants to draw from the limitations of more, more simple or straightforward theories of cognition and behavior. The sort of basic account is this reflex theory that we've talked about several times now. So this would be an account of like complex behavior in terms of these very simple atomic reflexes, this stimulus response pair, and then these reflexes would just get sort of joined together and form these more complex pools, these complex behaviors just by sort of association. And there's a lot of reasons to think that this is an oversimplification, and this is not adequate to account for behavior of animals, including humans. And so the sort of natural suggestion, or the first suggestion that comes to mind, is that instead of just having this very simple association, you would instead have a more complicated or more sophisticated form of integration going on in your brain that would take like these you still have these sort of atomic sensations as your inputs. They sort of get integrated or processed in some way in your brain, and then it produces some sort of output. And Merleau-Ponty argues against this this integration account. He presents a number of arguments, but the idea, the alternative that he presents essentially is that we can't sort of start from this atomic sensation level and then try to like build structure on top of it to add structure in later. We instead have to see the structure as being there from the outset. So perception is always structured. It's always there's always like even something very simple like color perception involves an interaction between elements and the structure in which they find themselves, as opposed to a simple point sensation, like a sensation of red being sort of self-contained and atomic, and then later being compared or connected in some way with a sensation of green. So we can only have something like a sensation of red in a particular structured setting. For example, like we have to appreciate what the ambient lighting is in the situation to be able to register what the color of a particular surface is. So what this shows is that our perception is always perception of a structured whole or an articulated whole, as opposed to a sort of atomic sensation being juxtaposed with another atomic sensation. And so he sometimes uses the term melodic for this kind of structured perception. So like, the idea here is when you perceive a melody, Twinkle, Twinkle, Little Star, or some simple tune that everyone recognizes like that, you can recognize this melody no matter what key it's played in. So you like the atomic sensations of tones might be completely different, but you recognize it as the same melody. So what you're recognizing is not some sort of association between one tone, like the first tone of the melody, and the second tone of the melody. Instead, you're recognizing the structure, the set of intervals going up and down that make up that melody, no matter which tones you actually use to sort of realize that structure. So yeah, this is he sort of uses this term melodic as like a sort of exemplification of this kind of perception where you grasp a structure as such, as opposed to first grasping the individual atomic sensations and then sort of putting them into a structure secondarily. So in general, this is the sort of counter picture of perception that he wants us to or his alternative conception of perception that he wants us to think about in opposition to the sort of standard accounts of perception. And this raises some sort of ontological question about what exactly is the status of these melodic structures or these articulated wholes that we grasp in perception. If we take it that perception is always a perception of a structured whole or of an articulated pattern of some kind, then where exactly do these patterns exist? Are they sort of in our minds, and then subjective patterns of some kind that sort of leads us back to again this conception of this atomic sensation being the real element, and then the pattern would be sort of secondary. If we take seriously the notion that perception is always perception of a structure, then it seems like we have to attribute a certain reality or ontological autonomy to these patterns, so that we can't just take them to be in our minds, but we have to think of them as something that exists, not exactly independently of us, but that has its own sort of self-subsistence, that's not sort of subjective in the traditional sense of the word. So what exactly we're supposed to make of this ontological status of these patterns is not, I think, fully clear yet at this point in the book, but there's something to think about as we continue reading the rest of the book. Okay, so let's start from page 101. I think we're at the top of page 101, if I remember correctly, if someone else would like to read from there.
I can read. Even in these cases least favorable, either quote-unquote trials involve no internal law, then they never result in learning, or there is learning, in which case the organism must be capable, on the one hand, of creating relations among the different possible quote-unquote solutions, and on the other hand, among all of them and the quote-unquote problem by which their value is measured. Even when the relation of signal to goal is a relation of pure succession, as happens in Tolman's experiment, we can presume that learning does not consist in recording de facto contiguities. It is necessary that the succession in itself, en soi, become a, quote, succession for the organism, unquote. This is possible in Tolman's experiment because the curtain, the alley which it signals, and the goal together enter into a spatial structure which has a meaning. But if one accustoms a cat to obtaining its freedom by scratching or licking itself, the animal reduces this movement little by little until it becomes imperceptible and does not renew it in a case of failure. If it is a question of obtaining a piece of food by a gesture which is without objective success, the animal, in executing this gesture, does not look at the goal. If, on the contrary, there is a relation which we will call logical between the conditioned stimulus and a natural stimulus, the animal does not take its eyes off the goal. One is clearly obliged to note that in the second case, the goal has acquired the power of evoking, in addition to the motor reactions of the visual apparatus, which in fact converge with them. Finally, the rhythm of the movements, their distribution, and the coordination in time are different depending on whether the response in question has meaning and is related to the very essence of the problem, or whether, on the contrary, it is a stereotyped reaction evoked by an aspect of the situation which is abstract and external to it. How did the conditioned reflex theory account for these variations of behavior which correspond to a like number of internal connections between the goal and a preparatory reaction, since for this theory all relations are equally external? Behaviorism opposes an objection of principle to these descriptions, in saying that the acquired reaction is related to the essence of the situation, that it admits of a series of variations around a fundamental theme, and in distinguishing true solutions from the results of training by the continuity of the movements which they integrate and by their melodic development, we would be attributing characteristics to observed behavior as if they were essential to it, when they are only the result of our human manner of perceiving and interpreting such behavior. It is for the human observer, who compares reactions distributed in different moments of time, that the acquired aptitude is general. It is also for him that a continuous curve is distinguished from a broken line. If we consider behavior objectively, that is instant framework of real stimuli which initiate it, we are never dealing with anything except particular movements responding to particular excitations. All of the language would be quote-unquote anthropomorphic, but it would still have to be explained why this so-called anthropomorphic interpretation is possible with respect to certain ways of behaving and impossible with respect to others. Even if we have been at fault in employing words like quote-unquote essence or quote-unquote problem, which were convenient for purposes of description, there remains the statistical difference between an organism which, after training, has acquired the power of responding to a definite stimulus, and an organism which, after learning, succeeds in varied adaptation to situations which are themselves varied. If one refuses to take into consideration as the object of science every property of phenomena which is not manifested in the intuition of a particular case, and which appears only to reflect reflective consciousness, by an analysis of the varied accordances or by a reading of the statistics, it is not anthropomorphism which is excluded, it is science. It is not objectivity which is defended, it is realism and nominalism. So actually, rereading that first paragraph, I think we may have done that. Read that one last time, but I guess it seems like the idea there is that if the relation between the behavior that achieves the success in whatever the experiment is arbitrary, there is less of a response from the animal that's being tested. But if there's a more obvious logical link between the goal and the behavior or the gesture that achieves the goal, there's more engagement from the animal, which would be a difficult difference to explain on the conditioned response theory. And this point about behaviorism, I think part of it is that even if these descriptions we've been attributing to the animal behavior are just anthropomorphism, there's still the matter of the statistical difference between variable learning and mere conditioned response. And also, this point is a bit more vague to me, but it seems to be saying that if we can't attribute something to what is observed that isn't in the observed perception, then science itself would be impossible.
Yeah. So there's a couple things in that bit that maybe we can go over one by one. So in this first part, he talks about the difference between two sort of versions of a learning experiment. So like one would be you're training an animal to perform some sort of arbitrary behavior that has no intrinsic connection with the goal that the animal, or the reward or whatever it is that the animal gets out of this experiment. So you can think of anyone who has like a pet, maybe you've tried to train them to do like funny tricks or whatever, I don't know, stand on their hind legs or something that is just sort of arbitrary and not connected to their like natural behavioral repertoire. And you can do this. You can reward them for doing these little tricks or whatever. Give them a treat. But the animal, like, you can see that they're sort of confused by this whole thing. They don't really understand what's the point of like standing on your hind legs and what's the connection between that and getting the treat. Whereas other behaviors that are sort of connected, that the animal understands what it is they're doing, like what's the connection between this action that I'm performing and the reward that I get. The animal behaves in a very different way. Like if we just sort of describe the animal like naturalistically, we don't try to limit ourselves to what we think is a scientific vocabulary. If we just describe the animal's behavior, we say the animal is like trying to catch the decoy or the whatever the experiment is. They're trying to do something. You can sort of see what the animal is trying to do. And then so the sort of objection that you would raise, like from a behavioristic standpoint, to this kind of difference is that you're just sort of anthropomorphizing the animal, and like you're just transposing our sort of human understanding of behavior onto this animal, as opposed to doing actual scientific description of what the situation involves. So you, like using terms like saying the animal is trying to do X, you're just sort of imposing a human understanding of their behavior onto what you're observing, as opposed to just describing scientifically what the animal is doing. Merleau-Ponty's objection to this sort of argument is that what we're doing when we, even if we're using some, terminology that could be described as anthropomorphic, what we're doing is actually recognizing, statistical differences in terms of these two types of learning experiments. Either learning to perform this arbitrary behavior or learning, to grasp the sort of intrinsic connection between a certain behavior and a certain reward. So even if we use language that is in some sense anthropomorphic, we're actually grasping a real difference in these two types of experiments, and sort of limiting yourself and avoiding attributing this kind of difference isn't really, like, it claims to be sort of more scientific, but what it's actually doing is like not allowing yourself to recognize this difference that is not sort of given to you in immediate perception. And science in general involves what's often described as inference to the best explanation. So you observe things like meter readings, or like what color the chemical turns after a reaction. And so, like, the sort of what is given in perception is often a very limited set of responses, but on the basis of those responses, you infer things about entities that you can't actually observe. So you don't just say, I mixed these two chemicals and then the results turned blue. You say that, given that this reaction occurred, I'm inferring that the substance has this property or this chemical structure or whatever. So you make inferences that about things that you can't actually observe based on what you do observe. And so Merleau-Ponty here is just saying that if you sort of limit yourself to this supposedly scientific description of the animal's behavior, you're actually just preventing yourself from doing what any scientist does in their normal accounts of different phenomena, which is to infer, to go beyond what is actually given immediately in perception or in observation, and make inferences, come up with explanations for what they observe, and so on. So this, supposedly scientific approach is actually, preventing yourself from doing science in like the sort of normal sense or the normal practice of science, as opposed to this sort of idealized version of what science should be, which is, this purely descriptive, observational science. Yeah, and so Angus has put in the chat here like a sort of parody of this kind of purely descriptive science. You would have to say, like, even saying like there is a dog in the room or whatever, you're sort of going beyond what is immediately given in perception. What is immediately given is a dog-shaped brown patch in the middle of your vision, of your visual field, and then at the next time of observation, you have a dog-shaped brown patch slightly to the left of the center of your visual field. And so if you're just doing pure observation, that's all you can report, whereas any sort of normal observer would just say there's a dog moving to the left or something much more straightforward. So, and it's not the case that this sort of first very artificial description is like more objective or more scientific than the sort of common sense description of a dog moving to the left. So like we denying yourself the capacity to make normal judgments about animals' behavior is not necessarily more scientific than attributing intentions to the animal, saying it's trying to do a particular thing, or trying to achieve a certain goal or whatever. So yeah, like just the fact of limiting our vocabulary doesn't mean that we're being more objective. And Bats has put in the chat here some comments about like the early 20th century logical empiricism, which there's different versions of this, but Russell at one point argues that the only thing, he talks about this distinction between knowledge by description and knowledge by acquaintance, and he thinks that the only thing that we have actual acquaintance with, or this sort of direct knowledge of, is sensations or sense data. So like colors in your visual field, for example. And then everything else that we think we have knowledge of is this sort of secondary form of knowledge, knowledge by description. So like even the most sort of banal everyday statements like the coffee cup is on the counter or whatever. This is something that you're actually sort of inferring or reconstructing based on the sense data, the patterns of color patches in your visual field, and then you sort of perform these inferences, and that's what sort of gets you to the very sort of obvious statement that the cup is on the counter. And I mean, Russell later on, I think, is more critical of this position, but like there's like all sorts of problems that come up, like for example, on this very sort of limited empiricist theory. It's hard to understand what the connection between one moment and the next could ever be. Like what's given in observation is always only something present. So how do I know like that this coffee cup that I'm looking at now is actually the same coffee cup as the one I saw 5 seconds ago, and not like a different coffee cup that produces the same sensation in me that has been switched in the 5 seconds since I looked at it. You have to sort of and so this is of course something that Hegel had already sort of made fun of in the phenomenology. This idea that the only sort of real perception or the most sort of objective perception is just a very limited sort of indexical statement. So it always depends on something like now or here. So like when you say now is night, that's like the most objective statement that you can make. But of course, Hegel points out that this statement is, if you just wait 12 hours, turns out to be false. It was true and then now it's false, or vice versa. And it's this seems to be a very strange property for a true statement to become false just by waiting 12 hours. Or here is a house, might be true, and then you turn around and now it's false. So like these sort of very straightforward indexical statements turn out to be, to involve more logical structure in the sense that they involve some sort of reference to a temporal situation and a spatial situation in which the speaker is located. So even these supposedly immediate statements like now it is night actually involve much more structure and the capacity to understand what it means to say now in relation to previous and following times. So yeah, even this supposedly immediate knowledge of what is present now to me actually involves understanding the difference between now and later, for example. And so like again, we can't sort of start from this very immediately given and sort of build things up from there. We have to already have that structure of grasping the difference between now and later just to be able to say something like now it is night.
I think the seems like the theory of perception that Merleau-Ponty himself has would make that kind of the at least from whatever period of his writing, Russell's idea of there being this kind of pure sensation of color would make that impossible in the first place. And there isn't really an atomic sensation already mediated, I guess, by its being part of the whole situation of perception. It's always seems like a figure always stands out as a figure against a ground.
Yeah, I think that's right. Like the Russell or this sort of more generally sort of empiricist account of perception wants to take these atomic sensations like a color patch in this portion of the visual field, and then there would just be another color patch juxtaposed to it, somewhere next to it, and then sort of on the basis of this mosaic of color patches in your visual field, you would like perform inferences about what objects are in your environment. Like based on these color patches, I can infer that there's a coffee cup on the counter in front of me. So this is like completely contrary to the way that Merleau-Ponty wants to describe perception, which is that you are always perceiving structures, and sort of more generally, those structures are always related to the structure of interaction between the organism that you are and your environment. So you never just sort of passively receive sensations and then sort of make inferences about what objects are around you, and then on the basis of those inferences make decisions about what actions to perform. Instead, the whole sort of action perception cycle is like sort of a unitary process where you as an organism in that has certain needs and desires and so on, are involved in adapting constantly to a changing environment that offers opportunities for you to satisfy those needs. Also presents dangers that you have to avoid. This sort of I guess you could describe it as a kind of tension involved in this perception-action nexus. There's always this sort of driving force behind it, as opposed to just this sort of passive reception that the empiricist accounts describe. Perception is always like a way of adapting to an environment to further some sort of life project of an organism, as opposed to it's this active and dynamic process, as opposed to this passive reception. Yeah, it's a little bit off topic, but it's interesting here in connection with a joke that Bats put in the chat here about gnomes switching out parts of your computer every time you stop looking at it, so it's no longer the same computer. There's actually our visual perception is actually so in humans there's part of your retina called the fovea, which is like a small region near the center of the retina, which has much higher visual acuity, surrounded by a larger region which has very low visual acuity, but can detect movement very well. And so we don't necessarily notice this in our sort of everyday perception, but we have a small region of clear vision, like whatever you're actually looking at, the object you're fixated on, and then surrounded by that you have like this very blurry region that you can detect movement like out of the corner of your eye. If someone sort of walks past you can see it, but you can't get a good, like if someone just walks past you while you're reading a book, you can't say what clothes they were wearing or who it was or whatever. You just sort of see a vague movement out of the corner of your eye. Normally we don't necessarily notice that we have this sort of structure of a clear center and then the blurry outline in our visual field, because our eyes are constantly moving. We hardly ever just stare at something for more than a fraction of a second. Our eyes are moving around, so we have our sort of experience of the visual world is that we have access to detail and clear picture of the whole visual surrounding at any time, because we can always just move our eyes and fixate any object. But there are these experiments that you can do where they use cameras to track your eye movements while you're reading a page, like on a computer screen, for example. And so the camera can track which word on the page you're looking at. And then while you're reading the page, the computer screen actually changes the words surrounding the one you're looking at. So your fovea, the central region of your retina, can see, I think, about 3 words on either side of the one you're reading. And then everything outside that region is outside the foveated region of your retina. And the person doing this experiment, so the one whose eyes are being tracked, just sees the page completely normal. They just read the page and everything looks normal. But someone else standing to the side and watching the page as the person is reading it will see the whole rest of the page changing constantly as the person scans the page and reads the text. So our visual system is only capable of registering the actual words on the page in a very small region, and when you're looking at that region, you don't actually notice the changes happening in the whole rest of the page. So it's there's much our sort of capacity to grasp the world as like a structured whole that Merleau-Ponty is talking about here doesn't necessarily mean that that grasp is accurate in sort of picking up all the details at the same time. So like when you look at a page of text, for example, you sort of grasp it as a page of text. You understand, this is a page of text. It's made up of words. It has a meaning, and so on. So this structure is all sort of present at once, but the perception of each of those words requires scanning the page and fixating the words one at a time, so like our detailed perception of the scene or the page of text, for example, is not something you can just sort of receive all at once. You have to actually, over the course of time, scan the words, scan the lines of text, and absorb what they say. And while that is happening, the other parts of the page can change without you even noticing it. But yeah, I guess these experiments are obviously coming much later than what Merleau Ponty is describing. So these require computer screens and eye tracking cameras that did not exist at the time he was writing. So I think it does suggest at least a sort of limitation of what he's talking about, in the sense that we can't necessarily draw epistemological conclusions from this sort of structured perception that he's talking about. So it's not the case that we can just avoid questions about the reliability of our perceptual capacities, just by appealing to this notion of structured perception that he's proposing here. So we can have this structured perception of the world, but that structured perception could, in many cases, not actually be accurate in certain respects. Or maybe another way of saying it is that which elements of the world we do grasp in that structured perception are limited by various aspects of our perceptual system. The structure of our retina, for example, in this case, like you only have this small region that has clear visual acuity and so on. So yeah, like just because we have the structured perception that he's describing doesn't mean that we have this sort of magical capacity to grasp all of the structure of a situation in one go. We still have to examine the details over time, and we can still make mistakes about the nature of a situation or what the structure of the situation is. Okay, let's go on to the next bit. If someone can read from page 102, Scientific Laws.
Okay, does this work?
Yes.
Okay, nice. Scientific laws, which are not given in the facts, but which one finds expressed in them, would be subject to the same grievance. When one speaks of the structure of the situation and its meaning, these words evidently designate certain givens of human experience, and are consequently suspect of anthropomorphism. But quote-unquote colors, lights, and pressures, or their expression in physical language, are no less so. It is clear that all the terms of which we can make use refer to phenomena of human experience, naive or scientific. The whole question is to know whether they are truly constitutive of the objects intended, viz., in an intersubjective experience and necessary for their definition. Precisely the preceding observations show that we cannot treat reactions to the structure of the situation as derived or give a privilege of objectivity to those which depend on elementary excitations. For instance, the excitations received on the sensory terminations and the movements executed by the effector muscles are integrated into structures which play a regulating role in that regard. These structural processes account for the laws of learning which we formulated above. Since they establish a relation of meaning between situation and response, they explain the fixation of adapted responses and the generality of the acquired aptitude. In the stimulus-response schema, they bring into play not the material properties of the stimuli, but the formal properties of the situation, the spatial, temporal, numerical, and functional relations which are its armature. It is to the extent that relations of this kind emerge and become efficacious by themselves that the progress of behavior is explicable. An early experiment of Ruger presents us with these original properties of holes in behavior. A subject trained to execute on each piece in turn, but in a systematic order, all the operations necessary for taking apart a metallic puzzle, behaves as if he had no practice with it when presented with the entire puzzle. Learning acquired with respect to a part, quote unquote, of a situation is not acquired with respect to this same part assimilated into a new whole. Same in quotation marks, I believe. In other words, the real parts of the stimulus are not necessarily the real parts of the situation. The efficacy of partial stimulus is not tied solely to its objective presence. It must make itself recognized as if it were by the organism in the new constellation in which it appears. There is reason for distinguishing the presence of the stimulus in itself, and its presence, quote unquote, for the organism, which reacts. But what we have just said of the entire puzzle could be said of each of the pieces which compose it. It is not with respect to the luminous rays reflected by it that habit has been acquired, but with respect to the metallic piece considered according to its form, in the ordinary sense of the word, and its mechanical properties. Since the decomposition into real parts can never be completed, it is never as an individual physical reality that the stimulus becomes reflexogenic. It is always as a structure. Do I continue?
Oh yeah, there's just one paragraph left in this section.
Okay. If these remarks are founded, it should be possible, and it is necessary, to classify behavior no longer into elementary and complex behavior as it has often been done, but according to whether the structure in behavior is submerged in the content or, on the contrary, emerges from it to become, at the limit, the proper theme of activity. From this point of view, one could distinguish quote-unquote syncretic forms, quote-unquote immovable forms, immovable, I guess, and quote-unquote symbolic forms. These three categories do not correspond to three groups of animals. There is no species of animal whose behavior never goes beyond the syncretic level, nor any whose behavior never descends below the symbolic form. Nevertheless, animals can be distributed along this scale according to the type of behavior which is most typical of them. So we will speak of relations to space and time above all with regard to the quote-unquote immovable form. It is nevertheless clear that an instinctive movement tied to a syncretic situation is adapted to the spatial characteristics of the instinctual object and involves a temporal rhythm. The fundamental dimensions of space and time are found, if you like, at the three levels which we have just distinguished, but they do not have the same meanings at each level. In order to become the unlimited milieus that human experience finds in them, space and time demand symbolic activity.
Right. So first he sort of expands on what he said in the last bit about how scientific thought or scientific knowledge requires going beyond what is immediately given in observation. And so he points out that even something like a color, which seems as though it's something immediate. The types of color constancy phenomena that we talked about a few weeks ago show that this color perception is actually part of this structured whole in that the perception of the color of this surface depends on what you understand the ambient lighting to be in that situation. So even something that seems like elementary or atomic, like the color that you perceive in one patch of the visual field, depends actually on the place of that patch in the whole structure of the visual field. And so in some sense, you're going beyond what is directly given in observation, and you're not actually just describing the color of one patch of the visual field. You're sort of, even when you limit yourself to just describing the colors that you observe, you're actually describing elements in a structure as opposed to these sort of very straightforward atomic elements. And then, so he goes on to say that when you're describing the behavior of an animal and you try to limit yourself to the supposedly scientific, purely observational language, you are effectively excluding the actual kind of learning that an animal does when it learns to grasp a situation as such, as opposed to the sort of arbitrary association of pushing this button with receiving a reward, or performing these other sort of unnatural behaviors. So just by using this supposedly scientific language, you are actually making a whole sort of domain of phenomena inaccessible to science. So you can't grasp the difference here between these sort of arbitrary associations that animals can learn through training and the more sort of learning in the proper sense, where the animal learns to grasp the structure of a situation and how its behavior allows it to achieve the goals that it's trying to achieve. So yeah, this supposedly scientific description is actually sort of excluding a whole class of phenomena from science. And so more generally, like the last bit here, he's just sort of drawing the lessons from this. It shows that we can only ever understand behavior as it's given to the animal, or like the proper grasp of the animal's behavior is not the one that we get by describing it in these in this purely observational form, but instead it's the description of the behavior, sort of from the perspective of the animal. So we have to figure out what it is about the situation that the animal is responding to, as opposed to assuming that what we as scientific observers think is important is what the animal is responding to. So like this example of the puzzle that he's talking about with human subjects, it shows that the individual pieces or the manipulations of the individual pieces are not what the human is actually responding to when they try to solve this puzzle, or when they try to put together the pieces to form the whatever the completed object is. So you can take each individual piece and teach the person, the sequence of movements that they have to perform, with this piece. But then when you present them with the whole puzzle, they still make the same amount of mistakes that you would if you had never seen the puzzle before. So like the sort of learning of these individual movements for each part didn't actually contribute anything to learning the solving this puzzle as a whole. But instead, if you allow the subject to sort of explore the puzzle, to try to put the pieces together and figure out how they actually fit and so on, then the subject learns to take apart and put back together this puzzle without making mistakes. So what they're learning is clearly not just a sequence of movements that, like, perceiving this a colored object of this shape means that you perform this movement, this sequence of muscular contractions that move your hand in this way, and so on. Instead, what they learn is that these shapes fit together in this way, and if I manipulate them like this, then they fit together properly, and so on. So you're learning a structured whole, the functioning of all these different pieces in interaction with each other, and the perception and movement of involved in manipulating one of these pieces is not a sort of a real part of that structure from the perspective of that human subject participating in the experiment. And he points out that this sort of decomposition of the structured whole into parts, in principle, you could keep decomposing into more and more parts, finer and finer grain distinction. So like your perception of one piece of the puzzle, you can break that up into like the visual sensations, the color patches that you see in your visual field, and the touch sensations in your fingertips, for example, as you hold the piece. So you could say that these are sort of two separate elements of the situation, and then try to figure out how what the responses are that correspond to each of those elements of the situation. But it's clear that these parts don't really correspond to anything for the animal, for the human subject participating in this experiment. We instead have a grasp of the puzzle piece that I'm holding in my hand and the puzzle piece that I see with my eyes. We grasp them as the same object, and we manipulate the puzzle piece by turning it with our fingertips, and we track that movement with our eyes. And as we move the piece around, we can see how it fits with other pieces in different ways, and so on. So like the tactile sensations in your fingertips, the kinesthetic sensations in the muscles of your hand and arm, the visual sensations as your eye tracks the movement of the piece, etc. All these things are sort of part of this sort of unitary perception of the piece in in its relations with the other pieces that make up the puzzle. And so this decomposition, you could keep proceeding to more and more decomposed perceptions, and then try to figure out what responses correspond to those stimuli, but you're just sort of artificially cutting up the unitary experience and action of the subject into these arbitrary parts. So this is sort of I think the lesson of this first part that we've been reading so far. And then in this last paragraph, he introduces these terms that he's going to go into in more detail. But these sort of three levels of behavior: the syncretic forms, immovable forms, and symbolic forms. And he suggests here that all animals use each of these three forms, but different animals use different ones to different degrees. So there's you can sort of classify animals in terms of which of these forms is predominant in their behavior, and that's what he's going to introduce in the coming sections.
And a lot of these examples, the example of the puzzle in particular, reminds me a lot of of Heidegger. I know Merleau-Ponty was influenced by Heidegger and Husserl, but obviously for Heidegger, discursivity means that we always encounter things as parts of a whole, pre-given whole, which is meaningful for us somehow. But Heidegger either is not interested or is disdainful of examples from empirical psychology. So it's just cool to see this kind of research being used to support similar conclusions about human behavior.
Yeah, like in Being in Time, all the examples are drawn from sort of idealized like peasant life kind of thing, picking up a hammer and so on. And they're all sort of everyday, a big part of the book is about this notion of sort of recovering the structures of everyday life, of everydayness. And so he's sort of deliberately excluding something like experimental study of a subject that put the subject into this sort of artificial and unnatural situation, as opposed to our sort of our everyday structures of life, or what he describes as everyday structures for this sort of 19th century German peasants. Merleau-Ponty is definitely much more interested in psychology as an empirical science. But I think it's more a different sort of a direction of approach towards a similar type of idea, in the sense that he wants to see how these psychological experiments sort of point beyond what one sort of specific experimental setting can teach us, towards this this sort of natural grasp of the structure of an environment. So it's not necessarily this sort of peasant life, rural sort of environment that he has in mind. Like he gives, some of his examples have to do with more, I guess, Parisian life and the urban setting and so on. But he's still interested in, I think, this sort of prior grasp of the structure of a situation that we can only sort of reconstruct on the basis of these experiments. That the experiments don't necessarily show us what this prior grasp of a structure is, but through the limitations of some of these experiments, we can sort of go back to that prior grasp of the situation. So like all the different things, all the different phenomena that we observe in these psychological experiments, that the color constancy and so on, are just sort of aspects that sort of lead us back to this sort of prior grasp of the environment that is sort of part of what makes a human being, the kind of entity that it is.
The idea of space and time is limited milieus sounds pretty interesting. I haven't read the symbolic form section yet, but it's kind of exciting. For was the empty form of time is this kind of infinite form of determination. Will be interesting to see if there's any compatibility there.
Right. Yeah. I don't remember in detail what he's going to go through in that part, but I think what he's pointing to here is just the notion of space and time as like the way that Kant describes how any time is always a portion of time in relation to time as a whole. So like if you like any time that you can refer to is always before or after any other time or simultaneous with any other time. So time is this sort of infinite form in which specific time periods find their place. And likewise for space, like if you refer to a spatial location, you're always referring to it as north or south or to the left of or whatever some other location in space. So these sort of infinite forms in which specific times and places find themselves, I think is what he has in mind. So like are sort of like the more like immediate or I don't know, animal grasp of space and time is just this sort of grasp of space and time in relation to me. So like the computer screen is in front of me, the door is to my right, etc. These are sort of the more immediate ways of grasping spatial relationships. But then this more sophisticated symbolic grasp of spatial relationships says that, I am currently located in this city, in this country, on planet Earth, which is, at this distance from the sun. All these spatial relationships are things that I only grasp through language and maps and other symbolic forms, as opposed to this sort of immediate bodily experience of the relationships of objects to me in perception. So I think that's the kind of spatial and temporal structures that he has in mind here, that we always, like, when we employ this kind of spatial and temporal thinking, we are using our grasp of things like calendars and maps and verbal descriptions of locations and so on to situate ourselves in relation to these structures of space and time, where those times and places find themselves.
That's interesting. Yeah, Heidegger also has a kind of, at least in his reading of Kant, has a very different conception of time as a kind of infinite form, because I think he sees it as, time is the fall and a kind of plasticity to it, so that it can be determined, I guess, differently, but in equally primordial ways, so that like the experience of working on your car in your garage has a kind of equally original relation to time that the experience of being a clinical psychologist studying somebody at a university, like very consciously measuring, like timed reactions would have. But yeah, it sounds like Merleau-Ponty's has a different kind of infinite time in mind.
Yeah, there's a lot of different aspects of time that we could talk about here, and so like there's the famous time consciousness lectures that from Husserl that Heidegger edited for publication, which is probably one of Husserl's best texts. But yeah, so there's this sort of inner time consciousness, and this is something that Kant sort of alludes to in some places, but it's not. It's some of the more obscure passages in the First Critique, where he talks about how, like, just the fact of for something to be a consciousness in the first place, or to be an experience in the first place, there has to be some sort of internal connection between one moment and the next. Like, if you sort of imagine that there was one sensation and then another sensation, and there's no connection between them, then doesn't really make sense to say that those two sensations are part of the same consciousness. Like, there's nothing that sort of takes you from one sensation to the next one, or one idea and the next one, or whatever. There has to be some sort of internal flow or internal process or internal time consciousness or whatever exactly you want to call it, but some sort of passage of time has to be part of the experience of that consciousness for it to even be a consciousness in the first place. There's a sort of internal structure of time in consciousness, but then, of course, we also have this sort of intrasubjective time in the sense that you can, call a friend and say, meet me at noon at this place or whatever, and you each sort of roughly know when noon is and have a grasp of when to go to that place and meet the person, and generally it more or less succeeds. Sometimes people are late or early or whatever, but like it's still possible to coordinate with another person to agree on when to meet at a certain location, even though in some sense you each have your own internal time consciousness. So somehow our grasp of time allows us to not just grasp a sequence of sort of elements in our consciousness of ideas or sensations or whatever, but also to to coordinate with other people and line up my time consciousness with another person's time consciousness. But again, this is a sort of an everyday conception of time, which often sometimes you use something like a time on the clock, which is ultimately governed by like these sort of complicated processes with there's like standards bodies in different countries that synchronize the official time signals using like atomic clocks or astronomical observations and so on. So this whole sort of background is something that you don't really think of when you just tell your friend, I'm going to meet you at noon. But it's sort of part of the whole practice of coordination of how it's possible for me to meet my friend at noon. Involves this very complicated system of satellites and standards bodies that have meetings to decide these things. But then at the same time, our sort of normal like understanding of time often involves much more sort of approximate grasp of time, and so like Angus had mentioned earlier that Heidegger in Being and Time, he mentions like the time it takes to smoke a pipe as like a measure of time. This is sort of like his peasant fantasy timeline. But we use these sort of even when you do use clock time, when you say like something takes 15 minutes, you usually don't mean that like I'm going to start a timer on my phone or a stopwatch or whatever, and it's going to take exactly 15 minutes. 15 minutes means like a sort of not that long amount of time, something like that, something vague like that. Or I spent an hour working on my paper. Doesn't necessarily mean I sat down and started the stopwatch and then 60 minutes later I stopped it, and that was like the measure of the amount of time that I was working. So like and then like a lot of our everyday sort of knowledge of time is much more vague and much more connected to specific activities that sort of correspond to that time. So like and this is connected also with space, of course. Like you would say a certain place is far away, or for example, you would say it's far if it takes a long time to get there. But in terms of like spatial distance on a map, a place that's closer on the map might be further in like real travel time if the roads are structured in a certain way or there's too much traffic or whatever. So like the spatial and temporal relationships are not necessarily like straightforwardly objective measures, but instead it has to do with a certain practical activity of like trying to get from one place to another. And then maybe like a third level of temporal and spatial relationships is this like scientific level or objective level where you have these instruments and technological apparatus and specific institutions, social institutions that are designed to produce these reliable, reproducible measurements of time that don't depend on specific practical interests. Things like atomic clocks, satellite radio signals that are used for GPS, astronomical measurements, all these things that involve these complicated processes of measurement, and some of these measurement units of measurement, like a second or a meter or whatever. It actually turns out to be a lot more complicated than you might think to explain what exactly a second is, or what exactly a meter is. Like in the case of the meter, at one point there was a platinum bar that was used as like the standard for this bar is exactly 1 meter, and then we measure a meter by reference to this bar. But it turns out, of course, that as the temperature fluctuates, this bar will expand and contract slightly, fractions of a millimeter. And in some applications, that difference actually matters if you're doing nanotechnology or something like that. And so the expansion and contraction of this bar, which supposedly is your objective standard of what a meter is, actually affects your measurements for other phenomena. And so now, if I remember correctly, they use a certain wavelength of light as like the standard of a meter. But again, that requires measuring that wavelength of light, and all the technical apparatus that is involved in doing that, and so on. So yeah, there's this very complicated system of social institutions and technical apparatus that sort of makes up our objective conception of time and space as being made up of these units that can be measured, and being these sort of all-encompassing structures where every time and every location can be placed in these structures. And so yeah, these are at least 3 different sort of forms of time that we all master in some degree, to greater or lesser extent. And then so part of our understanding of time as just sort of everyday people is like being able to grasp all 3 of these structures and how they relate to each other, and we sort of do this without even necessarily thinking about it. But we're sort of part of this whole practice of time and space understanding that involves at least these 3 forms of time, and probably others. Okay, so I'm gonna suggest that we stop here today. I know it's a bit early, but I do have some other things I need to get done today, and we're at a section break. So unless there's any other questions or comments before we wrap up.
Nothing else.
Cool. Okay, so let's think about time over the next week, and hopefully the daylight savings thing will not be an obstacle next week, when everyone will have time to adjust. So thanks everyone for coming out. Thanks for your contributions, and hope to see you next week.